Hey everyone, welcome to a new video. In this video, we're going to be taking a look at the Niagara laser system that I've made in a previous video. In that previous video, I made a Niagara laser emitter, which we used in that particular video to make a laser sight for a weapon. But I also mentioned in that video that we can also use it to make an alarm or sort of security laser beam. So the same system, but obviously if you character walks past it, it then sounds an alarm or it triggers other things to happen. That's what I discussed it could be used for. Now I've had a few requests to sort of expand on that. And then most recently in the Discord server, somebody's asked if I could make a video about it or expand on it. So that's this video. So what I'm going to demonstrate here is what we're going to make. The requirement is you are going to watch, sorry, you are going to need to watch, the first 15 minutes of the previous video. I'll pop either a card up at the top or the link down below, or both, for you to watch. After the first 15 minutes, that's when we create the Niagara system, the emitter. Then you can pop back over here and watch it for this. So let's just have a quick look at what we've got. So you can see here in the game actually already, there's this laser beam going across this doorway here. It's sort of like a triple arm. And if I press play and we jump into it, I've actually muted my audio. Let's just switch this back. So you should be able to hear my game audio now. I muted it just to stop other things in the background being recorded. So we walk past this laser beam, and you should be able to hear now that really annoying noise. Apologies if that's extremely loud, but you can hear this little alarm that buzzes off every time I pass through it. So it's detected that somebody's there that shouldn't be there, and the alarm's sounding. Obviously, I've just got it set up where this plays when you're stood in front of it, but you can have it to loop and repeat and keep playing for as long as you want. The possibilities are so large here that I'm just going to set it up with the most basic, and then you can build on top of that yourself. So what I'm going to do is I'm just going to delete the blueprint that makes this run, and then we will talk through it on how to make it. So bear with me a second. Okay, so what we've got here is just I've just created a blueprint actor, nothing special, just an actor. And then within that, all I've done is I've added a cone, shrunk it down to 0.1 scale on all the dimensions. Whoops. So that's just a cone. I've coloured it orange just for aesthetics. And then what I've gone and done is I've added a Niagara particle system component. And then if you've just come from the previous video, what you can do then is with the Niagara component added here, you can go to the right hand side, select the system asset as the laser beam system that you've just made, and then you're pretty much good to carry on from here. Now, what I do in that video is I set up some user parameters so this beam can be manipulated with blueprint or code, and by default what I've done is I've done beam color, so we can change this to any color that we want. So for whatever reason we'll change it to pink, just stands out. And then the beam end, I've just defaulted it to 100, but we're obviously going to update that with a blueprint. We're going to pair it with a line trace, and instead of talking about what we're going to do, let's just do it. Okay, so let's jump into the event graph. Now, we're going to do a line trace, and a line trace is just going to fire a line into the distance, and it's going to tell us everything it hits along the way. And if it doesn't hit something, it's going to have sort of like a limit to it of how far we should fire a beam into the distance to look for stuff to hit. There'll be an end point. So we're going to set our Niagara system to match the same impact point or the end of the trace. So let's start that. Now we can do it with an event tick, which is just going to fire permanently forever, very quickly. But I think for this type of thing, we don't need that much repetition. So I'm going to opt for a timer, something that can be started and stopped. Most importantly, stopped. when it's no longer needed anymore, where a tick just constantly keeps going until the actor's destroyed. So let's do event begin player to get everything started. Event begin player, and then I'm going to do a timer by event. So if you've never used one of these, basically a timer by event, when you trigger the first execute, what it does is it loops an event. Well, it doesn't necessarily loop, but it triggers an event um, after the amount of time that you specify here, and then it also loops if you tell it to or not. So every time it gets an execute, this event triggers after the time you specify, and then loops if you require it. We do require it. Now, a timer can be stopped by using the clear and invalidate timer. And what's rather useful is if we promote this to a variable. So then we could just call this timer handle. So you've got a variable that you can call anywhere. You can just drag this out, get timer, and then clear and invalidate, and it will stop this timer. So you can put that. I don't know if you're doing level streaming or something like that. You can deactivate this when your character's not, or stop this when your character's not in range or whatever. I'll leave that up to you, but that's rather useful. Event. What event are we going to do? So we're going to do a custom event, and we're going to do update beam or laser beam. There you go. Oh, update laser beam. Missed a letter. Laser beam. And I want this to happen quite quickly. I don't want it to miss somebody running past, but I don't want it as quick as a tick. There'll be a sweet spot for you depending on the size of your character and what scenario you're in. But I'm just going to go for 0.1. 0.1 second. I think that's quick, but it's not quite tick quick. And I want it to loop. I want it to keep updating all the time. Next, I need a line trace by channel. So by channel, here we go. Oh, yeah, it's probably worth mentioning I've switched back to my little headset just because it's got slightly better background noise cancelling, and I can't promise my background's going to be quiet the whole time. So let me know what the mic quality is like. If it's awful, then I will skip using this again. But if it's not too bad, then I might continue using it because it gives me a bit more freedom to make videos with my noisy children or running around in the background playing. Okay, so line trace. Added the line trace. We need a start and an end location. Trace channel is going to be left as visibility, and I'm just going to leave the. I'm going to change the debug type, the draw debug type to for duration, just so we can see it in action. Okay, so start location. Now this is just going to be get actor location. Whoops, that's not the right one. Get actor location. So get actor location is going to return this actor, the actual laser beam itself. So that's perfect for us. So start from where we are. Now we need to know which way we are facing, and we need to add a distance to that direction to get sort of our end point. So what we need to do is we can get actor forward vector. So this is which way are we facing forward. That doesn't have a distance associated to it. So if we do a multiply and then right click on this bottom node here and convert it to a float, this number is going to be the distance. So I'm going to do 500. That should be more than enough considering I'm only in a doorway, which is probably only 100 units or 200 units wider than most. So 500 will be fine. Obviously, granted, if you're moving this around or if you're going to be putting it, you can set this to 2000 if you want. But if you know the distance between your two things is quite short, 2000 is unnecessary, and there's no reason to do that. So I'm going to go for 500. And then what we're going to do is we're going to add that to our starting position. So this is where we're starting from, and then this is going to be what you can consider as an offset. So let's add 500 forward from that direction. So add that together just like that, and then we'll pop that in, and that should be our end position. So this should be fine. So we should have a line trace coming out of our laser beam now. every 0.1 second. So what we'll do is compile, and we can just have a quick look at that. Now, there is a laser beam coming out at the moment, and it's just going to It's just going to. Oh, that's the origin of the world. So that's 000 because it's not got an end location yet. So it's just set itself to 0. Um, there's a fix for this, but we'll get to that. So I'm going to hit play now, and I should see my line trace here. So I can see the line trace is coming out of the beam as expected, and it's hitting the wall just there. And then the rest of the beam is green, because that's the remainder of the trace. So realistically, I could set this to probably about 200, just to save that extra bit over there, but that's absolutely fine. So the line trace is working, that's good enough for us. Let's go back to our laser beam. Great, so line trace works. I don't need this for duration anymore, so let's just get rid of that. So that's set to none. Out hit, so anything that my line trace hits along the way, it'll be in the hit result, and so the wall that it's hitting on the other side is going to be a part of this. Okay, so what we need to do now is we need to tell our laser beam to basically go to the place that we're hitting with our line trace. So I'm going to grab the Niagara particle system and just drop that down here, and we're going to set beam, or what is it? Set vector parameter. There we go. So components particle system, and then set vector parameter. It's going to ask us for a parameter name. Now what we can do is click on the Niagara system, and then because you've followed my video, you should have a user parameter called beam end. Now this is case sensitive, so make sure you follow that correctly. So what we'll do is beam end as it's exactly there, and then the parameter that we're going to take in is a vector, because we'll set vector parameter. So we want the impact point. So we'll just pop that straight into there, just like that. And what we'll do is we'll plug that into there. So now if we compile and we hit play, we should see that our beam is now actually hitting the wall as we expect. That's great. So we can run in here, and if I look down, it should stop on my leg. There we go, so it doesn't carry on, it goes and stops on the leg. Now obviously I've got this set up where the capsule component of my character doesn't block anything, but the actual mesh of my character does. So you can see when I move just a little bit, you can see that the beam's going straight between my character's legs, which is realistic in my opinion, but that you might not want that. The beam's actually going slightly through the leg there. Anyway, but this is working. This is working. So the beam is updating as and when. So if you had this beam on a moving object, it would update to whatever it's hitting. Now there is a chance that depending on where you're putting it, it might not hit anything. You might just want it to laser out as far as it can until it hits the end value, so 500. Now if you want that, what you can do is you can do a select node. So do a select vector, and what we're saying is if this boolean is true, we're going to pick A. If it's false, we're going to pick B. So basically, from the break hit result, we can say, is it a blocking hit? So do we hit something with our line trace? Yes. Okay. Let's do something then. So put your blocking hit into your pick A. So if we hit something, use the impact point. If we don't hit something, so B, use the trace end, which is just down here. So what this is saying is, well, it's pretty much saying that if we hit something, use the impact point, and if you don't, just use the end of the trace. That way your beam will always update somewhat correctly, and it depends where you place it. So that's all updated, so that's absolutely fine. The next thing is we want it to play a sound. So what we can do is as we walk through, the thing that it's hitting is going to change to our character. So the hit result is going to return, I'm hitting a character now, not a wall. and we can decide to do something different with that. So using this hit actor sort of output from the break hit result, what we can do is we can say let's cast to a character. Now this is not a specific character. My character is called, well, it's not called anything, but he is the ALS Animan character. But what he is eventually down the chain, he is of a class character. So if we try and cast to a character class, my guy is going to return true. Obviously, if you're not using characters and you're using sort of spawns or pawns or something else or vehicles or anything like that, you'll just need to cast to the sort of one of the parents or the actual. You can cast to the ALS Animan if you want to limit it just to this, but I'm just going to go for character because then it catches sort of anything that I might want to hit. So if I can cast to a character, it must be me or it must be something I want to detect. So this is just a good way to check for characters. So if it fails, it's obviously a wall or it's something else. It's just not a character. And if it succeeds, it's something that I want to trigger an alarm. So I'm just going to use this as a sort of a funny catch-all. Now, one thing I do like to do before I try and cast the stuff is use an is valid. Now, realistically, it might not be totally necessary in this scenario, but it's good practice just to put an is valid in because this could be a brick wall. Granted, this will just fail, but it is probably good practice to have an is valid on something that can be invalid, technically. So is it valid? Yes, then try and cast to it, and if it's a character, we will be successful. Then what we want to do is we want to play a sound. Very simple, play a sound. Now I don't have a very good sound effects, so I'm just using a VR confirm. Confirm. Yep, just a little tweak, just like that. Now let's compile and let's play it and let's just see what happens. So we run through and it plays a little jingle. That's pretty much it. Oh, that sounds horrible. So if you stand on it, it's just playing a lot of the sound over and over and over again. So what you can do, if you want to, you can do a do once, just like this, do once. Add a little delay, just like that. 0.2 is fine, and then once this is complete, that just wraps around over that. I'm just going to double click on this line just to put a reroute node. Double click again to grab another, just to make this look a little bit nicer. So it's just going to wait a little bit before it triggers another one. Still annoying, but it's not like 100 sounds on top of each other all playing together. That's absolutely fine. Obviously you can increase this to a minute and that'll just delay how many play. So you can mess around with that. That's one way that I've done it. Now, if you want it to just keep looping for forever or for however long, you could just do another little event here, an event timer. So let's just delete that. So if we can cast to a character, what we can do is timer by event, just like this. What event do we want? Custom event. We're going to do play alarm. Whoops, alarm. Just like that. How often do we want it to run? Every second, just so it's not really annoying. We want it to loop. What do we want to do on our play alarm? So we're literally just going to do play sound. Now we don't need to do a delay because this timer is going to delay it for us. Now one thing we should probably consider is every time we trigger an event, it sort of restarts the timer. So if this is going to be constantly like every 0.1 second going start timer, start timer, start timer, start timer, this is actually never going to fire. So we actually probably want to do a do once here. And then once this is completed its little sound, We can then reset it. There are more elegant ways of doing this, but this works. It's cheap and it works. It's nice and simple. So we'll do it once, wait for the timer to finish, play a sound, then it'll trigger again, and it'll kind of loop itself anywhere. Yeah. So what we can do, run through. Did I set a time? Oh, I didn't set a sound. Oh, I'm glad that was the reason. I hope it plays now, otherwise I'm going to look silly. So you can see now, we've set off the alarm. Oh my god, there's an intruder. Enemies are going to start swarming the area and chasing you out, or all the safety doors come down and lock you in, or something like that. Obviously, now you can set sort of like a number counter here, so after 10 rings it stops. And when you re-trigger it, you know, possibilities are endless. Like I say, it depends on your scenario. Now, one thing I want to do before I go is obviously in the editor. Now, in the game, your laser beam is going to work perfectly, but in the editor, it's always going to go to the 0 point until you press play and it gets that update. Now, what you can do is this first part here, the line trace and the laser beam being updated, you can put this inside your construction scripts. So over in the construction script, I've already placed this here just to save a bit of time, but this updates the beam in the editor only. So if you put it in the construction script and played the game, it wouldn't update, but whilst you're in the editor, it will. So if I go back to the game, you can see that it's over there, looks horrible. But if I go back to the beam, hit compile now, you can see that this construction script has ran. You can see that my beam now looks nice, and because I've got another one over there of the same class, it's updated that one too. So you can see that in the editor they look how they would in the game, but obviously just bear in mind that when you press play, this construction script won't function. So have your active code in here and then just chuck the first bit in the construction script and it'll update in the editor. So that's pretty much it. I hope that helped. If it did, please consider giving me a thumbs up. If it didn't help, give me a thumbs down, I guess, but please tell me why. You know, if something I hate the most is if somebody dislikes it, please tell me why. I can work on it. Yeah, if you want to see more videos like this, please consider subscribing. Obviously, this came from Discord, so please feel free to join the community down below. Obviously, you can get in touch with me, ask me questions, send me videos, send me screenshots. And it's not just me there. There's plenty of people asking questions. You know, you might get some information from it. It's free to join, so why not? And subscribe if you want to. I'll leave that with you. But thanks for now, and I'll see you in another one. Bye.